Again, I started this, so you know who I am. And let's begin the question. Rich, Kevin, are you on with me?
Yeah, can you hear me?
I'm on.
Kevin's here. Can you hear me?
I can hear you, Ken.
Okay.
So thanks, guys. Welcome. Let's start with the obvious question. What's the difference? Kevin, you come from an industrial background. Rich, you come from a mission critical background. What's the difference between an industrial factory and a mission critical data center in general?
Yeah. Okay. So I guess that's really the topic for discussion. So just a short intro on me. So yes, I've been working in mission critical or in data centers for the last 8 or 9 years, but I did start in the industrial automation space where Kevin is. So and we've really been trying to address the concerns in data centers from that industrial perspective that you mentioned in your intro. And I guess so. We've had a good chance to kind of really examine the different mindsets within the data center industry and how they are different or what can be learned from industry in the data center business. When I think about what the key differences are, I think about it in two different ways. One is from a construction perspective. How is the topic of building a data center different than how somebody approaches building a new industrial facility? And then also from an operational perspective, how are they treated differently operationally? And to me, the major difference from a construction perspective is that when someone sets out to build an industrial facility, they don't kind of separate the sort of shell of the facility from the content. In other words, if you go set out to build a factory, you're not building a building with a factory inside. You're building a factory.
Right, exactly. Kevin, is that what you've seen? I mean, I think we talked in the prelim, and it was about if you're pick somebody, if you're Bayer Aspirin and you're building a new plant to make aspirin, you actually start with the end in mind. Whereas in data centers, we seem to start with the building and then stuff it. Does that sound right?
I suppose. I mean, if you go back to, I've been with ABB for 34 years, or going on 34 in the industrial. All those pictures you showed earlier. And, basically we take, in the industrial sector, you take a raw material and you convert it to another material that can be used for something. And so at the surface, a paper mill is a lot different than an offshore oil rig. But as we're growing here, and if you look at, your pinwheels you showed, those are all kind of what we as humans use, pictures and photos and videos and music but in the industrial sector, people are like, well, we don't do that in industry. Well, the data that is coming out of industry is starting to look a lot more like what us people use. So we're having, analog inputs, digital inputs, AO, we've got, facial recognition. We have cameras on our processes. And so the amount of data that is coming out of our facilities is exponentially rising. Actually, that's what the Industrial Revolution 4.0 that's part of my function, is to figure out how to use this data to drive better performance or reduce cost or improve quality. And then the two spheres kind of overlap in the terms of the things that you mentioned earlier: power consumption, safety, alarm management, cybersecurity. Those are now becoming massive issues on the industrial sector. Now we have all this gobs and gobs of data, and in the industrial sector, people are like, well, we got to learn how to save it. And I'm like, well, you guys have already figured it out. And then the things you're asking with regards to power management, and we've already figured out. So the fields I don't see them, the Venn diagrams are overlapping where they're natural extensions of each other. That's what I'm seeing.
No, that makes sense. I think that leads into the question around, the data centers are maturing, we'll say, as an industry, and with that, we see the need to be more business focused, and one way to do that is automation, of course. But yeah, classically, Rich, I think you and I have both been to control rooms where you see a lot of disparate systems, and everybody goes, yeah, I'd love to have this thing more automated, but how the heck do I do it?
Right, and of course, that's a similar problem to what industry faced maybe 20 or 30 years ago, where again, getting back to the construction of the data center, when it's built with these silos. I mean, what industry called islands of automation, where you'd have different components of the production that sort of manage different steps or different portions of the facility. And over the course of years, and as technology evolved, industrial production realized that sort of islanded approach was not serving them well. Having all of this disparate information, disparate systems, different skill sets to manage the different IT technologies that went into the facility, were very difficult to manage. So they basically broke down the silos. They combined the islands, and now if you build a industrial facility, you put in an automation system, one kind of control and data system to manage everything. You start with the end in mind, and then you can operate that facility effectively. And the numbers kind of have borne that out over the years in industry. So in terms of downtime, in terms of energy efficiency, asset utilization, personal productivity, all of those metrics benefit by having these systems consolidated, so that you get that one overview of what's going on in the facility. Data centers still haven't quite caught up to that. They still tend to think in these siloed terms. So as you say, you can still walk into the operation center or whatever in a data center and see the BMS display in one place, the EPMS in another place, different modes of operation, alarms get managed differently. It's difficult to see how that can't change as customers want to become more efficient. They want to get better visibility, and also their facilities are changing. I mean, they're much bigger. They're much more mission critical even than they were before. So, this is following the same patterns that we've seen in industry.
Yeah, and I would echo that same thing. Is when we started, there was a time that our control systems, in the early '80s, you're like, well, if it went off, would it really hurt you? And people are like, well, no, I don't know. Well, now if I say if your screen goes black that you use to run your machine, people are like, oh no, that can't happen. And just recently, we're getting into what you started with is, if your data goes down, and you can't predict where you're going, so you don't know the road ahead. And so now that's where in the industry space, we're emerging to build in connectivity to larger storages of information and data. That's becoming a bigger design. But it wasn't until, we'd already built, 30, 40, 50 years of stuff, and now we're trying to figure out how to integrate with these solutions. It's a scale issue. And I think that's what you're seeing in your world is, I used to just have I have a series of CDs. I still had floppy disks from 8.5, inch floppy disk on my wall. Now, everything I've ever done in my life fits on a chip the size of my fingernail. You can see the space is growing and growing and growing as you showed that exponential curve. So that means more power, which means more heat, which means you got to handle it. And that's where now you have more, you talk about trips and alerts and downtime and recovery times. You just can't do what we've always done and expect to do 100% uptime. So you have to have automation and control systems in place to visualize that. Or
that's a great point. That's a great point, Kevin. And really, my view is obviously there comes a point where the complexity outstrips what you could see, or how do you manage that complexity? And that's really where the tying different systems together. Obviously, forget the optimization part of it. It starts with being able to visualize what's going on, how to manage those alarms, things like that. That's definitely something that we need to do. Does that mean, if more things are connected, doesn't that bring you into different, more things can fail? How do we work through that?
Well, if you can't measure it, you can't control it, right? I mean, that's paraphrasing, I think, Lord Kelvin's statement. Everybody wants to be able to control their environment because they want to be able to control their costs, and they want to be able to manage their performance and reliability. The more complicated your environment is, the more you need systems to help you get a handle on what's going on. And if you're running say that again?
I call it the sphere of influence of our folks. It's like, when we used to, all you had to know was how to fix a valve. If it stopped, it was a pneumatic valve that you could go and grease it. Well, now I got to know the IT space, the OT space, the SAP space, the hard drive space, the control, automation, HMI. The number of technological stacks to get something to work has grown past what any one person can know. And we're in a spot where you can't add people for every sliver, because then you just can't. And then if I have a person doing physical rounds where they physically go around and touch things, I still remember looking at the LEDs on our old control systems, and I could say, oh, that one's breaking. You just can't do that. So our sphere of influence of humans touching everything is shrinking, but data is growing. So we have to learn how to expand what a person does and be able to, like you were saying, is put smarter technology to do predictions. And that's one of the nice things that ABB brings to the party is we make majority of the automation, telecommunication, electrical components. We know what good is supposed to look like. And so we can start to predict, hey, something switched over here, you should go look at that. And so instead of waiting for the failure, you can get a horizon in front of you, and then you can empower your employees to have better visibility, better access to experts, the IC, what you see, kind of, HoloLens, that kind of stuff, where you can bring in subject matter experts when you need them.
Right.
So that's the shift that we're seeing in industry, is to connect our engineers digitally to subject matter experts no matter where they're at in the world.
Yeah, that's obviously a big bonus. And once we have the information, I got to think that's where you can start optimizing things as well, right?
Well, yeah, and it is true. That's what's happening. Is especially, COVID did not start the Industrial Revolution, but it certainly sped it up. And so where customers were used to just calling us and they could allow us to drive to site, then they're like, well, we can't even have you come on site, but we really need this problem fixed. And so that's where, a lot of the stuff we even had to rethink. Well, you have to be on site to see it. And we're like, oh, well, we can deploy some of the technology and have someone that is committed on site to provide that information back to somebody in near real time or real time. And it just completely transformed a lot of our business practice thinking. So, sometimes that's what, you get to a spot where you have to make a change, and then the digital is there to do that.
Yeah, the whole notion of complexity, really drives some of the technology discussions. It works from a number of perspectives. I mean, you still have, a limited number of people that need to be able to manage and operate more and more complicated environments. And that's been true in industry, and that's also, true in data centers. I think the skill sets, drive people to require knowledge of broader and broader systems, and that that means that you need systems, technology systems, software systems in place to support that. If you have one person now that's trying to manage a large hyperscale data center, and he needs to know everything about the cooling and everything about the electrical and everything about the fire systems, and it's a lot of data. It's a lot of skill that somebody needs. So having those software systems in place to support those people is key. But it also enables new types of business models and new types of relationships, even with vendors. So what ABB sees with some of our industrial customers is we stay much more connected to our customers' operations through technology than we ever have before. So we offer programs where we are connected into their systems. This connected engineer model where we may already be working on issues that turn up in a customer site, at the same time that the customer is being made aware of it, because we also have people that are intimately familiar with the kinds of problems that customers might encounter. And so again, that technology and that learning from other industries, is directly applicable to data centers, especially when you consider that a lot of data centers now are actually employing people that come from other industries to manage their facilities. So they're already familiar with the kinds of technologies and roles and responsibilities.
Well, I think you touched on a couple interesting things I'd like to explore more, Rich. And first of all, the point about if we start to pool the data we're receiving from the components, obviously that allows us, hey, we've already seen this, and we know that Tuesday, if it's 78% relative humidity, we might have trouble with the bearing in this motor or something crazy like that. So we can get beyond the break fix maintenance to something more proactive. And then the second part, cooling. I mean, cooling is the second biggest load in the data center, with the drive towards sustainability, not just on the compute side, but also on the facility side. I got to believe all this can really be driven home and perhaps accelerated by paying attention to this.
Well, I would even say, one of your slides there where you showed the constant energy, but the volume of data is going up. And I just was like, I wonder if you could optimize that. And so in the industrial space, we've been using advanced process control and dynamic models where you try to look for, where you might be using too much. And we get this a lot in power, like on a boiler system is, a lot of times people will run their boilers at high pressure so that if anything blips, you have a little bit of room. And then once you realize you get better control and better runnability, you may be able to back off on that to save energy and not, adversely affect your process. So you have safety factors, and that's called, advanced process control. And that's the kind of thing that I've been seeing requested from data centers is, can we apply APC techniques to different things in our facility? So yes, you can.
And what kind of metrics do we use in data centers, Rich? I mean, we've all heard of PUE, where you measure the total power in versus the total compute power or something. That there's some limits to that, obviously. Are we looking at newer ways to try and get some kind of miles per gallon out of a data center?
I'm sure we are, but I don't know that there's anything that's really been well established as a better metric. I mean, PUE still seems to be the metric used for, design and operations. And sure, when the focus is on, maximizing your cooling efficiency, then PUE makes sense. I guess, in my view, as data centers evolve and the things that are driving growth in data centers continue to evolve, things like 5G and Internet of Things and things like this. There's going to have to be increased focus on the sort of overall heuristic data center energy demand, right? So not just cooling, but how the whole data center sort of operates together, the IT and the facility working hand in hand, and that's kind of the sort of last silo, I guess, in the data center is how do you actually manage the data center as a completely integrated unit. And I don't know the answer to that specifically, but I know that that's the way that managing the data centers is going to have to go, because demand on data center compute and data management is not going down. It's going up, and probably going up at a faster rate than we've ever seen before.
Yeah, for sure.
And that's going to mean energy consumption is going to go up. I don't know how that, flat line that you showed on the slide is how much longer that can persist, even if the efficiency of the data centers continue to increase to match demand. It seems like demand is going to outstrip that at some point. And so again, looking at the total unit and how it can be managed efficiently is going to have to change. And just looking at the kind of load models that you can predict. I mean, you don't have to be a futurist to say, if I'm going to have all of these edge data centers that are managing the telemetry from, self-driving cars or whatever, that kind of load is going to be very dynamic, right? And so, your IT load on the data centers themselves may fluctuate greatly over the course of the day. So, how efficient is a data center that's running but has no IT load on it? How do you calculate that? Even if your cooling costs are zero, you're still spending money on IT.
No, exactly. That's a good point. Kevin, is there in industry? Do you think that there's some parallels we can draw, some methods we can borrow around fluctuating loads, things like that? And I think of like a foundry or something. I don't know.
Yeah, I mean, a lot of it is we need to kind of learn each other's lingo. You talk about PUE. I mean, I'm looking at OE. Overall equipment effectiveness has sort of been a driving function, and there's different. Is the system available for use? And if it's available, can it run at the design performance levels that it was designed for? And if it can run at that, are you getting the quality out of the that you need to sell your product? So those are the worlds that I live in, and then you have to couple that with the cost to produce. So I've been to places that kind of forgot the cost to produce and drove everything on available quality. But they didn't bring in, the cost of raw materials. So you have to balance it. That's a constrained optimization problem. And usually we sit down, there's so much in an industrial plant, especially with the electronics and the digital age coming upon us, that people are like, they kind of get the deer in the headlights look. And I don't know, maybe that's on your side, you're now coming into industry, but you got the data part. So you're like, I don't know what to do. And so that's where we came up with some methods or questionnaires or workshops. This came from our oil and gas sector, where safety is a huge deal. If you do something wrong in a gas plant, it explodes. So are you safe, reliable, or optimized, and can you demonstrate it? And that's where you have different asset classes, and then you have that are physical things that you touch, and then you have different functions like loop, alarm, safety, cyber, that kind of stuff. And then you have your process dynamics, which is different based on the industrial sector. But then you just sort of help someone prioritize, well, shoot, I don't even know anything about transformers or distribution or circuits or breakers or trip or fault log, and then you say, okay, let's start there. And can we optimize that? So those are methods of helping. You can't, this elephant, to eat it all at once. A lot of these places have been around for a long time. So we are, just by the nature, we've developed the silos, and then you break the silo to have bigger umbrellas covering the facility. And I think that's where you guys are going into that. And so maybe we can help, and you can certainly help us with data. What do we do with all this data?
No, for sure. And I think one thing that has changed is at one time industrial plants were kind of closed loop communications, and 15, 20 years ago I like to say we kind of peeled the roof off and poured in the internet and stirred, and then a lot of the problems with that, specifically cybersecurity, data security, all kinds of different things we know have happened, including some new things I'm hearing about is where nefarious agents will actually poison AI systems by feeding them bad data so they don't work right. And is that something? I know we consider it on both sides of the aisle, so to speak, here, the data center side and the industrial side, as well as product development side. But what is that? What's happening around that? What are we doing to help address that?
Well, data integrity and data security is a massive thing that is growing. And rightly so. It's like if you gave me all your, if I said, can I just go to your bank account and play around with your numbers for a little while? You'd probably say no. And so, that's where there's a little bit of that with all of our sites. They're very, very protective, and rightly so. And so helping them see that you can have that level or even more by utilizing a data center approach. It's like, it's kind of like, when I used to have a phone that had a cord on it, my folks, and when they went to digital, they still stand at the same place that their cord was. Like, you can walk around now. And I think part of this is to work through that. But the issue you were mentioning about there are bad guys out there that can find holes in firewalls. We've seen I've seen cases recently where there was a company broadcasting, looking for holes. They would show themselves as a vendor. They'd go to the front desk and say, "Hey, I'm here," and then they would say, "Hey, you want to pay us to secure your security breach?" And I'm like, "Well, that was a gutsy thing. Break in and then say, 'Hey, you want to pay?'" That just happened. So that's like, we have to realize that security and data and offsite data is a very, very big deal. And in the industrial sector, if people can blow things up, that's not good at all. But as we get more and more data tied to data stops and my whole site goes, that's just as bad. So those are things that are, I say, caution. We need to be cautious as we move forward.
And of course, there's a lot of time and effort being put into securing industrial facilities. I guess largely because, as you say, the roof has been peeled off to a certain extent. There is a certain dependence on, outside connectivity in industrial sites. So, they have to make sure that they're as bulletproof as possible.
Yeah.
And it's a little bit ironic that in data centers, there's still, a lot of this thinking that, from a facility perspective, as long as we're air gapped, we're fine, right? I mean, it's no problem. And that's, just not true, right? I mean, there are many attack points on an air gap system as well. They're just not as apparent or so leveraging that research, that work that's being done to protect industrial systems in data centers, should be done. And the irony is that on the IT side of the data center, of course, there's a lot of time being spent, thinking about cybersecurity, but that hasn't really jumped the gap over to the facility.
Yeah, I've actually seen that some of that OT will say some of the facilities cybersecurity has been passed back to the facilities team because on the IT team it's so consumed with the IT side of cybersecurity that they really don't have the bandwidth to use or to track down the facility side. So that's probably another place where we could help Kevin with our industrial approach on there. Imagine.
I certainly think so. I know that the internet has been added, but the air gap, we still hear about that. Then there's the USB ports. We got to lock all those down, and it's just that's not a viable solution anymore. It's just think that you can stop things. We found people. We actually have profiles, and you find Angry Birds playing an operator station at 2 a.m. That's probably not the best use of that operator's time. So we have to do stuff like that to just make sure people don't load, YouTube video watcher on their, operation. So, that there's internal things going on. But the amount of data that is growing and consumed in the industrial sector is forcing people to have to now learn VMs and data storage and all that stuff. And industrial sites, either they make paper or they make oil or they don't. We need to learn to leverage the expertise in other areas. Right. And that's where linking or working with data centers it's going to be, if not already, a part of how we move forward to grow, or we can't expand.
Oh, for sure. Are there specific skills gaps we're seeing in terms of the operators in industry in general? And I know in data centers, Rich, you and I have talked about this. Maybe that'd be a better place to start.
Well, the interesting thing is that data centers, I mean, since they are experiencing such heavy growth, I mean, they're drawing a lot of people from the industrial world. It used to be that, I'd go and visit a data center and explain my background in industrial automation and get a lot of blank stares. Now it's just the opposite. I mean, I'm talking to people who have been drawn from, the pharma industry or other industries that ABB has sort of more traditionally dealt with. So there's a really solid understanding in the data center business of industrial technologies. It's just getting the industry as a whole to kind of recognize that there's more that can be shared or more that can be learned. It helps everybody. I mean, it also creates this larger pool of people to draw from who can help manage the skills shortages in the data center business.
Yeah. Yeah, I think we're kind of an unknown industry. Everybody knows it connects to a data center, but nobody knows that it needs people to work there and specific skill set and everything else. Everybody wants to be on the front end of the tech business, it seems, the tech industry.
Yep.
But anyway, so all this in mind, we've covered a lot of ground, obviously. I think that this has been a tremendous conversation. Any last thoughts by either one of you?
Well, I guess the future is, it is scary, but it's extremely exciting to see what we can do when you merge data with the industry sector to forecast issues, to optimize performance, to improve operating, components to provide better quality of life for our engineers and our customers. I mean, we're literally in a frontier that is opening up to us, and I think it's an exciting time to be in this space. I'm thrilled that I'm still in the game, and I remember when we had pneumatic controllers trying to tune those, and now we've got thousands of controlled items now, and we can't do what we used to and expect it to be different. We have to embrace this, and that's where the innovation comes from. So it's an exciting time.
Great. Rich?
Yeah, from my perspective, sort of similar comment, but I'm always surprised and pleased at how many technologies are able to bridge the gap. I mean, the new features, the new functions, the new types of products that we're building out for oil and gas or something like that. And I'll sort of maybe casually mention it to one of our data center clients, and they go, "Wow, that's something that we can use, right? That will help us in our operations, or help us manage our maintenance costs, or something like that." These conversations are always extremely interesting and exciting. So I think it's just a question of doing more sharing, more discussions like this. And everyone just sort of keeping awareness that there are lots of interesting sort of tangential or associated industries that be learning from.
Yeah, we can learn from. No, exactly. Well, very good. I thank you both. I hope the audience enjoyed that, because I always learn something talking to you guys.
Well, thank you very much.
Thanks, everybody.
With that, we'll change our speakers and go on to our next topic.